We navigate our daily world in meters. It is the practical scale of a single human stride, the height of a doorway, or the length of a city block. Applying these familiar units to the scale of the cosmos causes our mathematical intuition to fail. The numbers rapidly expand into streams of zeros that the human brain cannot naturally process. The distances involved create an overwhelming void. If our entire solar system were contained in a giant sphere, all physical mass, every planet, moon, and the sun itself, would occupy only 1/1,000,000th of the total volume. To map this emptiness, astrophysicists use this logarithmic staircase called the powers of 10. Notice the right side, where the scale increases geometrically. Every step outward multiplies our field of view by 10. We simply add a 0 to keep the numbers manageable. Zooming out by just a few zeros shifts the observation from the mechanics of human movement to the immense gravitational systems that govern the structure of the cosmos. At 10 to the 7th power, 10 million meters, the entire Earth finally comes into view. From our perspective on the surface, the planet is a rugged landscape of mountains and trenches, but at this cosmic scale, the Earth is remarkably smooth. If you dragged a giant finger across its surface, it would feel as polished as a billiard ball. The total height difference between the deepest ocean trench and the highest mountain peak is about a dozen miles. Against a planetary diameter of 8,000 miles, that variation is statistically negligible. Because of this near-perfect spherical shape, astrophysicists use the planet as a primary measuring stick. The distance from its center to the surface is a standard unit called 1 Earth radius. Converting the Earth from a place into a mathematical unit provides the baseline required to measure the much larger objects in our solar system. Adding one more 0 brings us to 10 to the 8th power. Here we encounter Jupiter. It is 11 times the radius of the Earth and over 300 times its mass. Jupiter is a gas giant with no solid surface. Its interior is so pressurized that hydrogen is forced into a liquid metallic state deep beneath the clouds. That immense mass serves as a gravitational shield for the inner solar system. Jupiter's gravity bats away incoming long-period comets that would otherwise threaten rocky planets like our own. Moving outward by just 1 power of 10 has shifted the local reality from a rocky homeworld to a massive liquid metal protector. Zooming out to 1 billion meters, 10 to the 9th, the Sun completely dominates the field of view. This star is roughly 100 times the radius of the Earth. While the Sun appears as a massive, explosive furnace, its internal energy generation is surprisingly quiet. The actual power output in the Sun's core is about 300 watts per cubic meter. That is equivalent to the heat of a few household toasters spaced several meters apart. The Sun's luminosity is the result of sheer volume. It contains a massive collection of these low-output toasters, while its optically thick outer layers trap that heat inside for thousands of years. Adding this final 0 has transitioned our observation from a passive gas giant to a self-sustaining luminous star. We have bridged the gap between rocky planets, gas giants, and stars by simply shifting between 10 to the 7th, 8th, and 9th meters. This scaling allows us to convert these massive bodies into functional tools. We use Earth, Jupiter, and the Sun as the basic units of measurement for everything else we discover. It takes exactly 7 powers of 10 to scale up from a single human being to the size of the Earth. From there, it takes another 19 steps, a total of 26 powers of 10, to reach the edge of the observable universe. These 26 steps on the logarithmic map bridge the gap from a single human eye to the furthest reaches of space, compressing the infinite into a single navigable scale.